In this video, I'm going to cover all of the setup options that are specific to each analysis type. So the first thing I want to do is check off all of these options so that they're all enabled. And if I were to run an analysis right now, all 6 of these would run, or excuse me, all 5 of these would run. First, the noise analysis, you can either choose or find a pulse that's either high, low, or any type of pulse. And you can define the cutoff time that defines noise. By definition, noise is an extremely narrow pulse compared to the normal signal behavior. In fact, a noise pulse is often just 1 or 2 logic analyzer samples wide. So you should always enter a cutoff time about equal to the sampling resolution used to capture the trace data. For example, in this case, 1 gigahertz sampling was used to capture this trace. So I've entered 1 nanosecond as the noise cutoff time. The normal signal behavior is about 10 nanoseconds wide, which is much wider than this. Next is pulse analysis, and all of the options are the same except for you can choose any type of pulse of high, low. You can decide whether you want to find pulses that are too narrow, too wide, or both, too narrow or too wide. And depending on which type you choose, you have to define an upper and lower boundary. So we could find any pulse in the data that's less than 10 nanoseconds or greater than 100 nanoseconds. Next is the bus value analysis. This feature compares the trace values for channel group or serial bus. For example, you can verify if the correct values were sent across an I2C or SPI bus when burning an EEPROM chip. And this is the one type that lets you choose trace data, reference data, or serial bus conversion. And when you choose this, you need to have a serial bus capture. If you're using trace or reference data, you can only use a channel group to compare the values. And if it's serial bus conversion, then you'll have to choose a serial bus from this list. The comparison values can be generated as a pattern you define, a series of specific values, or you can load an ASCII text or binary file which contains the correct values that will be compared to the trace data. The resync after each error option finds the next trace value which matches the first comparison. The comparison then continues from that location through the end of the trace data. The ignore first error feature skips the first non-matching value in the trace data. Combined with the resync option above, this allows you to sync with the data beginning at the first sample in the trace data. When using a channel group, always enter the approximate time width for valid bus values. This is not necessary when using a serial bus. The time width is used to ignore brief invalid transitions which may occur between valid values. This allows timing analysis modes to be used to oversample the signals. A base value must be entered when using a pattern comparison. The same base value can be compared to all trace values, or it can be automatically incremented after each comparison. These auto-incremented patterns can be limited so that it repeats at a smaller value rather than the channel group maximum. In this example, a 16-bit bus is selected, so the pattern repeats when FFFF is reached. But the pattern could repeat every 256 values using the limit option. So I can limit it and choose every 256 value the pattern will repeat. The series type of comparison is very simple. You choose from 2 to 8 pattern values, and then you enter the specific values. The series comparison repeats throughout the entire trace data. Finally, you can load a text or binary file to define the comparison values. The data type width must be selected from the size list. Text files must contain 1 value per line, while binary files are loaded in raw data values are loaded as raw data values with no other information in the file. The comparison analysis is performed in the time domain so that conflicting sampling rates or sampling methods can be compared correctly. For example, trace data captured with 1 gigahertz transitional timing can be compared accurately with reference data captured using 50 megahertz normal timing. Now there's no source trace option in this because you must have trace and reference data open at the same time in order to compare it. So all the options here have already been covered. And finally, The Custom DLL tab is used to activate and configure custom analysis DLLs you have created using the GoLogicXL Analysis Development Kit. So you can select one or more DLL descriptions in the list to activate the modules, and then click the Setup button after selecting a DLL to configure the custom options for that DLL. Not all DLLs have options, and it will depend on the DLL that you have installed. If the DLL description is highlighted, then it is active and it will be used the next time you run an analysis. The Analysis Development Kit, or ADK, allows you to create these custom analysis tools that have direct access to the GoLogicXL trace data, and you need to download the ADK from our website to learn how to create these custom tools.